All right, students, I'm going to show you the decomposition of hydrogen peroxide. Hydrogen peroxide, you will probably be familiar with that because it's a common household item used to predominantly to be used as a disinfectant on scrapes and bruises and things like that that children might acquire. Now, in the decomposition of hydrogen peroxide will break down into water and oxygen gas. That process is slowed down by the fact that hydrogen peroxide is stored in dark bottles. Light actually helps to accelerate that decomposition reaction. But when hydrogen peroxide decomposes, it releases oxygen gas, and of course, gas will produce bubbles as it comes out of a liquid. Now, as you can see here, the hydrogen peroxide has been sitting here outside of its bottle here for a while now, and as we look, there's not much bubbling that we see. Now there is oxygen that's being released. It's just such a small amount that we cannot see it. Now the question is, what would happen if I added a chemical? This chemical is called manganese dioxide. This manganese dioxide is not a reactant, which means it does not react in this decomposition reaction. It's not a product, meaning it's not produced by this decomposition reaction. But I'm going to put a little bit of manganese dioxide in there with the hydrogen peroxide, and let's see what effect it has on this decomposition reaction. As the student can see, now we get a lot of gas coming out of there. That gas coming out of there is oxygen gas. And of course, oxygen gas is flammable. It's what you need for fire to burn. And I've got this little match. I'm gonna blow it out and then stick it in there and see if I can ignite it again. And as you guys can see down in there, we actually got a little bit of fire on the end there. That's because that oxygen gas helps provide a little bit of oxygen that fire needs to get going. All right, so there is the decomposition of hydrogen peroxide. Go ahead and complete your data table and answer the questions that follow.